Okay, welcome back. And in this video, I'm going to give you the theory and an intuitive understanding behind how images are formed and how images are stored on computers. Honestly, if I had my own way, I would love to teach computer vision and machine learning without disturbing people with the mathematics behind this stuff. But this is one of the critical knowledge you need, and you need to understand how images are formed and to be able to conceptualize how the images you load from disk are actually stored on the disk, and then you will know how to manipulate them properly. So pardon me for this theoretical aspect, but it is very important that you understand how images are formed and how they are represented in a computer's memory. Okay, so to do that, I got these images online and I'm going to try my best to use them to explain to you. If after watching this video you don't understand anything, you can leave your comment on the video and I would answer you as soon as possible. Okay, so a computer image is nothing more than a two-dimensional array, okay, storing the red, green, and blue component of light that has been reflected by an object. So, for example, for your eyes to see an object, light has to hit that object and bounce off those corners and edges on the object. And once the reflected light hits your eye, there is a small opening in your eye that makes sure that the image that is formed is sharp enough for your brain to be able to interpret. And it is the same principle with which cameras operate. So if I point a camera at you, basically what the camera is recording is the light that is reflected from your body and anything that is within the focal view of the camera, anything that a camera is seeing at the moment. Okay, now once it gets into the camera, it is encoded. Okay, and like I said earlier on, an image is just a two-dimensional array of what we call pixels. So if this grid you are seeing here is an image, then it's going to be a 9 pixel by 9 pixel image, and each dot in memory is going to store the red, the green, and the blue quantities in the light that represent that particular portion of the image. And the reason it is red, green, and blue is because different quantities of these different colors mixed together is going to produce an entirely new color. Okay, so with these three colors, the red, green, and blue, you can be able to mix different quantities of them to come up with different colors. Okay, so when you load an image from the disk or from a URL like I showed you how to do previously, what you are actually getting in memory is a numpy array that has a number of rows representing the height of your image, and then the number of columns. So the rows is read downwards, and then the number of columns is read across the screen like this. So the number of rows represents the height, or how many pixels are in your image on the vertical, and then the column represents the width, or how many pixels are in your image on the horizontal. And each dot stores three values between the range of 0 to 255. 0 means the absence of that particular color. Okay, so if over here I got 25500 and I'm reading it in RGB format, what it means is that 255 red, 0 green, and 0 blue. So the pixel in that corner is going to be pure red. But if I had 255, 142, 120, then it means there is 255 red, 142 green, and 140 blue. Okay, so that is basically how your images loaded from memory or from URLs are represented in your program or in your computer's memory as a NumPy array. I have this image here which should help you understand things better. So it is actually a stack of the red, the green, and the blue channels. Okay, so if I had a 50 by 50 colored image, what you are actually seeing is a 50 by 50 array that stores the red component, a 50 by 50 array that stores the green component, a 50 by 50 array that stores the blue component of the color in each pixels in your image. So if I read the values at 0, 0, I would get the red component, the green component, and the blue component at that particular pixel. Now, if we are dealing with grayscale images do not use multiple channels, because in grayscale images, the values are stored from 0 to 255, and because we don't care about red, green, and blue, we only care about a shade of color between black and white. So 0 means the absence of color, that is going to be black, or the absence of light, that is going to be black. And then 255 is the presence of the maximum amount of light you can ever interpret in an image. Any value between 0 and 255 is going to be a shade of gray that gets whiter as you approach 255, and it gets darker. So as you approach 255 in the positive direction, and as you approach 0 in the negative direction, it becomes darker. And for this reason, most image manipulations are done on grayscale images, because obviously the mathematics involved in that is simpler, and most of the time we do not need the color component of an image to make sense of whatever content the image has as far as computer vision is concerned. So you know how to load colored images from disk and from URLs. You understand how images are formed and stored in memory. And I've also told you that we usually do image manipulations on grayscale images because the computations are much easier and it is not very expensive as far as computing resources are concerned. So I hope with this intuition you understand how images are formed and images are stored in the computer. If you have any challenge to understand this, leave your comment on the video and I'll do my best to explain to you. Okay, so thank you very much for watching, and I will see you in the next video.